Hey everyone, welcome to our channel. Today in this video, we are going to discuss a very interesting concept of cryptography, that is digital signature and RSA. So the first question that arises in our mind is, why do we need digital signature? Let's consider the scenario where your friend sends you a letter by post. Then how will you verify that it is sent by your friend only and was not tampered in between? I know your answer is by signature of your friend on post. Am I right? Then if this process is done digitally, you can do it with digital signature. One can create a software or website that offers digital signature services. Here in this video, we have covered four subtopics. The first one is encryption and decryption of documents. The next is hashing, followed by the steps required for generating digital signature, and lastly, the real life applications. Let's dive into encryption and decryption part. There are three types of encryption algorithm which are most commonly used. First one is RSA, second one is AES, and third one is bluefish algorithm. Here we are discussing about RSA algorithm. There are two main steps in RSA algorithm. First is encryption and second one is decryption. Encryption. It is a process to convert plain text into ciphertext using keys. There are different types of ciphertext for same plain text depending on which encryption algorithm is used for this conversion. There are two types of encryption. The first one is symmetric, where sender and receiver uses the same key to encrypt and decrypt the data. The second one is asymmetric encryption. Here both sender and receiver uses the different key to encrypt and decrypt a data. Now decryption. It is a process to convert ciphertext into plain text using keys. It's basically a reverse process of encryption. Now let's take a look at mathematics involved in RSA algorithm. First, choose two prime numbers and calculate n. Generally, these prime numbers are large in size. Let's say first one is p and the second one is q, and n is calculated by multiplying these two prime numbers. The second step is to find Euler-Tocient function of n, which is denoted by phi and calculated as shown. Now, in the third step, for public key, choose a number e, such that e must lie between 1 and 5, and GCD of e and phi should be equal to 1. For private key, D is modular multiplicative inverse of E as shown here. Here, public key is E and private key is D. Now, let us discuss advantages and disadvantages of RSA algorithm. First, advantages. The RSA algorithm can be implemented relatively quickly and efficiently. And the second advantage is breaking the RSA algorithm is extremely challenging because mathematics involved in this process is very complex. This gives it edge over other algorithms. The third advantage is the RSA algorithm is secure and trustable for sending private information. Here, distribution of public keys to users is very simple. And another advantage is for mechanisms, sending sensitive information carries no danger because RSA is dependable and secure. Now, disadvantages. It might occasionally fail because RSA only employs asymmetric encryption and complete encryption requires both symmetric and asymmetric encryption. Sometimes it's necessary for a trusted third party to confirm the dependability of public keys. Another disadvantage is that data transfer rate is slower relatively to modern algorithms. Decryption requires some processing on the receiver's end. Now, here comes the hashing part. The algorithm which is used by us for hashing is SHA-256 algorithm. SHA-256 is basically a hash function. Now the question arises is what is hash function? So a hash function is the function which converts message into digest or a hash value. The secure hash algorithm or SHA family of algorithms includes the SHA-256 algorithm. The 256 in the name refers to the final hash digest value, meaning that regardless of the amount of plain text or clear text present, the hash value will always be 256 bits. Output value of SH256 is hexadecimal number of 64 digit. Now we move ahead to our next topic, which is steps required for generating digital signature. Process is starting from sender's side. Step 1. Conversion of sender's message into digested message. As shown in the diagram, the plain text is passed through the SHA-256 algorithm to convert it into a digested text. Step 2. Conversion of digested message into digital signature using sender's private key. Equation here is signature is congruent to dth power of digested message mod n. The digested message obtained in step 1 is encrypted with sender's private key and digital sign is generated. The final step on sender's side is passing of digital signature along with digested text to the receiver via network. Now we are moving to receiver's end. Step 1. The receiver decrypts the digital signature using the public key of the sender and obtains a digested message. The equation suggests that digested message is congruent to eth power of signature mod n. Step 2. The receiver also converts the original message into digested message using SHA-256 as shown in the diagram. Step 3. The final step at receiver's end involves the comparison of both the digested message that is from the server side and the receiver side. If both the messages are same, then trust and accept the original message. If the comparison fails, then it suggests that the message is tampered. Now, let's see what are the real life applications of digital signature. First one is authentication. A pair of cryptographic keys, a private key and a public key, are created using the RSA algorithm when you want to digitally sign a document or conduct an online transaction. While the public key is distributed to others, the private key is kept private and only known to you. Another application is signing. Using a private key, you encrypt the document's hash, a distinctive representation, to digitally sign it. The digital signature is then appended to the document using this encrypted hash. Here we use SH256 as a hash function. Another application is verification. The receiver uses your public key to decrypt the digital signature and retrieve the hash in order to confirm the legitimacy of the document and the signature. They next perform their own computation of the received document's hash. The document has not been tampered with and the digital signature is legitimate if the two hashes match. Now let's verify algorithm on machine. The Python code displayed here takes a file as input as shown here. The file is then encrypted and digitally signed and a file name signed document is created as shown here. The code then checks both the initial and final PDFs and says success if both the files are same, as you can see in the terminal. Now you will find the source code of this algorithm on the website given in description. There you can explore more about RSA and digital signature. So do make a visit at the website. The report for this project is also attached there. Do like and subscribe the video if you find it helpful. Thank you.